Hi, Arcfieldweather.com meteorologist Paul Dorian here on Wednesday, October 23rd. It is that time of the year again where we like to take a look ahead at the winter season. We'll discuss many factors that were included in the preparation of the winter outlook here, and they're all available right now on the homepage of Arcfieldweather.com. If you want to go back and revisit any of the plots or maps that we'll show over the next several minutes, just go to the homepage of arcfieldweather.com. We're going to start off here with a listing of some of the key factors involved. First of all, I always like to take a look at sea surface temperature anomalies, not only in the Pacific Ocean, but around the world as well. Now, in the Pacific Ocean, it looks like we will have a weak La Nina event through the upcoming winter season. It does not look like it'll get very strong, but indeed, a weak La Nina event is likely right through March into April of next year, and then it'll likely become a neutral signal out in the equatorial part of the Pacific Ocean. Also, there's kind of a widespread area of below normal temperatures, water temperatures near Alaska, and that's kind of an interesting feature as well, and it certainly can play a role in the overall upper atmosphere pattern in the winter season. The Atlantic Ocean remains, for the most part, well above normal temperature-wise, and certainly that could have an influence on temperatures along the eastern seaboard and the mid-Atlantic region, for example, especially the coastal sections. I also love to take a look here at the prospects for high latitude blocking. High latitude blocking is characterized by higher heights than normal or higher pressures than normal over places like Greenland, northeastern Canada, Iceland, and high latitude blocking tends to be a favorable pattern for colder and therefore snowier weather in the eastern U.S. And there are some signals this time of the year that can kind of give us a clue as to the chances for high latitude blocking during the winter season. So we will go through a few of those over the next several minutes. One includes teleconnection indices known as the Arctic Oscillation and North Atlantic Oscillation. Another involves the snowpack this time of the year across the northern hemisphere, specifically Siberia. There have been studies that show the increasing snowpack in Siberia this time of the year can kind of give us a clue as to the prospects of high latitude blocking. And finally, the sun itself, solar activity, has been shown to be related to a high latitude blocking during the winter season. Whether or not there's a lot of activity or a little bit of activity can indeed have an influence on the winter season, specifically with respect to high latitude blocking, higher pressure than normal over Canada and Greenland, for an example. Finally, we'll walk through some analog years where I've gone back in the past and tried to find some years, in this case 5 separate winter seasons, that featured similar overall sea surface temperature patterns compared to what I expect to see during this upcoming season. By taking a look at the temperature and precipitation patterns during those analog years, it can kind of give us a clue as to what we could expect this winter season. Well, let's start off with the latest sea surface temperature anomaly map around the world, and again with a focus on the Pacific Ocean, but that's not the only area of interest here. First of all, notice all this blue out here in the equatorial part of the Pacific Ocean. This is La Nina that is going on right now. It developed within the past several months. We actually started this year with an El Nino event, warmer than normal waters in the tropical Pacific Ocean. That transitioned to a La Nina during the summertime. It continues this time as we progress through the fall, and it looks like we'll have a weak La Nina right through the upcoming winter season. So that is indeed a factor, and we'll talk about some of the implications of that over the next few minutes. By the way, this black line right here shows where the equator is, and this La Nina again is over the equatorial part of the Pacific Ocean. Also, take a look here near Alaska, the Aleutian Island chain right here. Pretty widespread area of below normal temperatures in the northern Pacific. That could play a role on whether or not a high pressure ridge forms in that particular part of the northern hemisphere during the upcoming winter season. And again, much of the Atlantic Ocean remains with above normal temperatures as we progress through the fall and head into the winter season. Well, the current sea surface temperature anomalies certainly show La Nina conditions right now in the Pacific Ocean. But why do I believe that will continue through the upcoming winter season? Well, one of the reasons is shown right here on this particular plot, where there's numerous computer forecast models and both types. We have dynamical models that factor in current conditions and statistical models, and both of these kinds of computer forecast models tend to agree on a weak La Nina event right through the upcoming winter season. What we are seeing here is the neutral line right here. This is the neutral line going across right here. Now let me clear that away here. Anything below that neutral line represents La Nina conditions in the equatorial part of the Pacific Ocean. This is specifically for the central part of the Pacific Ocean. La Nina being colder than normal water temperatures. El Nino above that neutral line, warmer than normal. It looks like in the winter season, here's December, January, February, March, and February, March, April. Right around this time here is the winter season, and most of these dynamical and statistical models agree with a relatively weak, but nonetheless a firm commitment to La Nina conditions through the upcoming winter season. Now, there are a couple of outliers that have a strong La Nina. Generally, anything at or below 2, for example, represents a strong La Nina in this case, or anything above positive 2, strong El Nino. But again, for the most part, we're looking at weak La Nina conditions here, maybe on the order of a half a degree below normal in that central part of the tropical Pacific Ocean. Now, what is a typical pattern for the winter, a La Nina winter? Typically, the polar jet stream, the northern jet stream, dominates. That's as opposed to the southern branch of the jet stream that may dominate during an El Nino winter. But this is a graphic put together by NOAA that shows kind of an average La Nina winter season with that polar jet stream, kind of the dominant jet stream, and the southern jet stream that can exist during the El Nino can move in this fashion here. It is often weaker or non-existent during a La Nina winter. So right here, you can see the polar jet stream will produce some cold air outbreaks into the northern plains, the upper part of the Midwest, with the origination of those cold air masses, northwestern Canada and Alaska. And occasionally, some of these cold air outbreaks will make their way all the way into the mid-Atlantic region, but the real concentration of colder than normal conditions in a La Nina winter are usually located over the northern plains, the upper part of the Midwest. And also, at the same time you get those cold air outbreaks into the northern plains, for example, a La Nina winter usually ends up with warmer and drier conditions across the southern U.S., specifically from, let's say, Southern California all the way into Florida. You tend to have warmer and drier conditions. There may be a dichotomy this winter in California itself, with the southern part of California on the warmer, drier side, but the northern part, as seen here, may be wetter than normal. That could result in another winter season of above normal snowfall in places like the Sierra Nevada mountain range up across the northern part of California. So again, La Nina winter, typically that northern jet is the dominant jet stream, the polar jet, bringing cold air masses from northwestern Canada into the northern U.S. Well, I talked up front about liking the idea of determining whether or not there's a good chance of high latitude blocking in the upcoming winter season. High latitude blocking, again, is characterized by high pressure, higher pressure than normal over places like eastern or northern Canada, even New England. but more specifically Eastern Canada, Greenland, and Iceland. And when you have high latitude blocking or higher pressure than normal over those parts of North America, that often results in colder than normal weather across the central and eastern states, which in turn leads to a better chance of snow. Now, there are a few different signals I like to look at during the fall season that can kind of give a clue as to whether or not high latitude blocking is favorable for the upcoming winter season. The first one right here we'll talk about are these teleconnection indices that we feature often during the winter season, known as the Arctic Oscillation and North Atlantic Oscillation, the AO and NAO. Empirical observations have found that if the trend is generally negative, let's say, in the fall season, it often remains negative in the winter season. Negative AO and negative NAO tends to be favorable for high latitude blocking. If, on the other hand, it's positive for the most part during the fall season, then that typically leads to positive AO and NAO index values during the winter season. So I like to take a look at the trend this time of the year. And frankly, it's pretty mixed. What we're seeing here is a mixed signal here. This is the NAO right here and the AO index going back a few months. And you can see the neutral line right here going across horizontal line here. So for several weeks here in September and first half of October, the NAO was negative. However, then it jumped up to positive territory and remains a positive territory, heading back down to neutral. So I think overall I would classify this as kind of a neutral signal when you look at both the NAO and down here the AO. It was indeed below the neutral line here in negative territory for parts of September and October, but then shot up to above the neutral line here in positive territory. So all in all, I'm calling this kind of a neutral signal for high latitude blocking events during the upcoming weekend. But let's take a look now at a couple other signals. Well, studies have shown that if the snowpack this time of the year increases dramatically over portions of the northern hemisphere, specifically Siberia, then that often leads to high latitude blocking events in the subsequent winter months, in the subsequent winter season. And specifically, again, that area of Siberia has been shown to be quite a good correlation between an increasing snowpack there during October and possible high latitude blocking events during the upcoming weekend. And from a physical point of view, it kind of makes sense. The deeper the snowpack this time of the year, the greater the chance of a deeper and deeper cold air mass setting up over those northern latitudes. And what we are showing here is the difference in snowpack from the very end of September on the left here to just a couple days ago, October 22nd, and this whole area in white. Now this is again on the other side of the North Pole, the U.S. down here. This is Siberia on the other side of the North Pole. Look at the dramatic increase in snowpack from the end of September, snow being shown here in white, to right now. So this, I do classify this as a positive signal for high latitude prospects, high latitude blocking prospects this winter season, again, because of this dramatic increase in snow over the first few weeks of October. Again, studies have shown a better chance for cold air outbreaks. Now, oftentimes these cold air masses originate on the other side of the North Pole over Siberia, and they certainly can cross the pole and enter into North America. So I'm calling this a positive signal. That first AO, NAO is a neutral signal for high latitude blocking, but this I will call positive. Finally, let's take a look here at the impact of solar activity. And we all know that the sun is the main driver of weather and climate, certainly on medium and long-term range, but even in the short term, it has been shown that solar activity plays a pretty strong role in high latitude blocking situations. And what I've done here, what I've produced here, are 500 millibar height anomaly maps. First, on the left here, in low solar activity winters. In other words, when we were experiencing a solar minimum for several years. And on the right, high solar activity time periods. And we are in this high solar activity time period right now. We are right around the solar maximum phase of the current cycle, number 25, and this solar maximum phase can last for several months. We've had a lot of solar activity over the past several weeks with northern lights, for example, and solar storms, coronal mass ejections. No reason to doubt that that will diminish too much over the next few months. In other words, high solar activity. Take a look at the dramatic differences in the 500 millibar patterns during these low solar winters and high solar winters. Right here, the low solar winter features this high latitude blocking right in this region right here. That's kind of a thick, let's change the thickness here of that pen. This orange area right here over places like Greenland, that's Greenland right there. Again, during low solar activity years, you have a very high chance of high latitude blocking situations, which again increases the chance for cold and snow in the eastern U.S. Whereas during high solar activity winters, you don't have that. You have more or less an upper level trough here over Greenland, northern Canada. So we are indeed in a high solar activity period here. So this I'm calling a negative signal for the prospects of high latitude blocking. So that's why, again, the summary up front, we call this kind of a mixed bag here with respect to these particular three factors here and the prospects of high latitude blocking. One was positive, one was neutral, and one negative. Well, in addition to looking at sea surface temperature anomalies, and in addition to looking at teleconnection indices and solar activity, I always like to take a look at analog years, going back in time and trying to find winter seasons that tend to mimic what I expect to see this winter season, specifically with respect to sea surface temperatures. And in this particular case, I've selected 5 analog winter seasons that featured a weak, maybe a weak to moderate La Nina that followed an El Nino winter, because that's in fact what we are going through right now. We are going to have a weak La Nina, but earlier this year, in January, for example, and in the winter season of 2023 to 2024, we had an El Nino event. So that those are the thresholds that allowed me to find these particular 5 winter seasons. And then I'd like to take a look at the temperature and precipitation patterns for those analog years to kind of give us a clue as to what we could expect during the upcoming season. What we see here for these 5 analog years is the temperature anomalies, and certainly there is a strong signal for colder than normal conditions across much of the nation. And I do temper my ultimate forecast here for the temperatures along the Mid-Atlantic region, along the coast, by the fact that, or due to the fact that the Western Atlantic is relatively warmer than normal here. That can have an influence here, but nonetheless, quite a signal here from these analog years for colder than normal. And this again is kind of goes in line with a La Nina winter in that the northern plains, the upper part of the Midwest, typically you are colder than normal. You have that polar jet stream bringing in those colder air masses, colder than normal air masses from northwestern Canada into the northern part of the U.S. And again, occasionally those Arctic outbreaks will make their way all the way into the Mid-Atlantic region, the northeast U.S. Now again, in terms of those analog years, this is the precipitation pattern for those particular 5 winter seasons that mimic the sea surface temperature anomalies that I expect to see over the next few months. Again, kind of mimicking that La Nina generic pattern we saw up front here with drier conditions across much of the southern U.S. And I do believe that will occur, but from Southern California, maybe to Florida, I kind of disagree with the finding here. I think Northern California probably wetter than normal, but kind of nearly normal across the northern half of the nation, a little bit uh, uh, above in some areas, a little bit below in some areas, but a pretty clear signal of drier than normal across the southern half of the nation. So based on all these factors we've looked at that range from sea surface temperature anomalies to solar activity, teleconnection index trends such as the AO and NAO, I've come up with the forecast shown here in our conclusion section here of normal to slightly below normal temperatures in the mid-Atlantic region for the upcoming winter season. It's anywhere from 0 to -1. 1 degree below normal is possibility over that winter season, and I'm calling the winter season November through March here. Certainly I expect to see some impressive Arctic air outbreaks all the way into the mid-Atlantic region and northeastern U.S., especially impressive Arctic air outbreaks for the northern plains and the upper part of the Midwest. But again, some of these will make their way all the way south and east into the mid-Atlantic region. In terms of snowfall for the mid-Atlantic, generally nearly normal, which in the big cities amounts to maybe 13 to 17 inches in the DC metro area, 20 to 24 in Philly, and 23 to 27 in the New York City metro area, slightly higher amounts in those northern and western suburbs. Elsewhere across the country, I think drier than normal conditions are likely from, let's say, Southern California all the way across to Florida, and the coldest temperatures relative to normal probably concentrated over the upper part of the Midwest and the northern plains. One final note here, the winter could actually get off to a pretty quick start in the mid-Atlantic region in the northeast U.S., with the possibility of some accumulating snow as early as the second half of November and certainly during the month of December. We may in fact go from still a highly active tropical scene in the Atlantic Basin during the first half of November to threats of cold and snow later on in the month of November. So that's it for now. We'll certainly continue to monitor all of these factors over the next several weeks as we head into the winter season of 2024-2025. That's it for now. For ArcfieldWeather.com, this has been meteorologist Paul Dorian.